All right, we are back. We are back with Unit 7, start of second semester. Who's excited? I am. I know I am for sure. Can you tell it in my voice? Okay, here we go. So today we are talking about polynomials. Now, polynomials are something that you have learned about since your second year algebra course. Okay, this is a brief little review. We're just going to talk about some definitions of some words, and then we're going to perform operations with polynomials like adding and subtracting polynomials. Okay, so polynomials look to be in this sort of form. This is called standard form, where our term with the highest degree is written first, and then we go in descending order. What are terms? Our terms are groups of numbers and variables separated by addition and subtraction. Okay, so if I look at our first example right here, I have 1, 2, 3, 4, 5 terms because there are 5 numbers and 5. I have 5 numbers or variables separated by addition or subtraction. Okay. Notice that 5x squared y to the third is one entire term here. Okay, that's not 3 separate terms. It's one entire term. The degree. So the degree of every single term is, you get the degree by adding the exponents here. Well, I only have one variable with an exponent, so my degree here is 4. The degree of this term would be 5. The degree of this term would be 8. This would be 0 since they're not a variable. And this would be 1 here. Okay. So I define the degree of my polynomial. It's named by the highest degree of any one term. So here my highest degree was actually 8 from right here. Okay. Now, something I forgot to mention that's very important. When dealing with polynomials, in order to consider something a polynomial, our exponents must be positive integers. Meaning, first of all, I cannot have x to the 3 over 2. That would not be considered a polynomial. Or x to the negative second would not be considered a polynomial, because this is a fraction and this is a negative. Must have positive integers. Alright. Polynomial named by the highest degree. Cool. Coefficient. Coefficient is the number in front of each term. Number in front of the variable of each term. The coefficient here would be 3. A coefficient here would be negative 5. 7. 3. Negative 19. This one's technically just a constant, not a coefficient, because there is not a variable. Alright, this would be negative 19. Now to determine our leading coefficient. The leading coefficient is the number in front of the highest degree term. Well, we said that our highest degree term in our first example was this term with 8, so our leading coefficient would be 7. Okay, would be 7. Standard form of any polynomial is when the terms are written from highest degree to lowest degree. So our highest degree term, we said, was 7 x to the third y to the fifth. Our next highest degree would be this term here, so minus 5x squared y to the third. Our third would be that term there, so plus 3x to the fourth minus 19y plus 3. I need to pay attention. Alright, it's a lot of times it's easier to rewrite your polynomial in standard form so you can see your highest degree term, which would then allow you to see your leading coefficient a lot easier. Now, if you're able to see this piece of information just by looking at how it's written, that is fine. But pay attention to directions. At times we may tell you to put it in standard form, and times we may not. Okay, so make sure you're paying attention to directions on that. Alright, for these next 4, all we want to do is state the number of terms, the degree of each polynomial, and the leading coefficient for that polynomial. So I'm going to use T for terms, D for degree, and LC for leading coefficient. So terms. There are 2 terms separated by addition and subtraction. The degree. Well, the degree here is 1, therefore my degree is 1. Technically, this would be a linear function. Functions with a degree of 1 are considered to be linear. Our leading coefficient in front of the x is 3. All right, next one. Term. There are 1, 2, 3 terms. Degree of our highest polynomial is 3. And our leading coefficient is 4. All right. Pause it. Try this. Try the next two. Or try the next one. Yes. Terms I came up with 4. Degree I came up with 4 as well, because if I add these two exponents together I get 4. And my leading coefficient, remember, if there's not a number in front, I can assume that it is 1. Okay. For this next example here, our polynomial is not in standard form, so I'm going to go ahead and rewrite it in standard form just to make my life easier. Again, pay attention to the directions to what they have to say. Okay, so terms, there are 3. Degree, sum of these two, which is 5. And our leading coefficient is negative 12. All right. Let's flip it. Here we go. Adding and subtracting polynomials. All right, so adding and subtracting polynomials, we're combining like terms. Okay. The biggest thing here is to find variables with that have the same degree, all right, and constants. Combine those terms, okay? The biggest thing when doing this, we have to be careful when subtracting polynomials specifically, because a lot of us make this mistake. If we subtract, it's like distributing a negative 1. So minus 2x squared minus 4. We need to be very careful with that. A lot of us make the mistake of forgetting to subtract the 4, so be very, very careful that you do not write this as plus 4, because we are subtracting the entire set of parentheses. All right, so I have 3x squared and negative 2x squared, which gives me x squared. Negative 2x is by itself. Same with the minus 4. Nope, that's not right. What did I forget? I forgot the plus 5. Oh, buckets. All right. Well, we're just going to battle. Watch this. Check it out. Check it out. Plus 5. So plus 5 minus 4 gives me plus 1. My apologies on that one. I made a mistake. Go figure. Everyone makes mistakes. Everyone does it, right? Or what is the thing? I don't know. You tell me. You figure it out. So anyway, multiplied polynomials. Okay. What do we do when we multiply polynomials? Well, if I have x times y and a times b, a binomial times a binomial, what would you do? You would think to yourself, oh, FOIL. First term, outer, inner, last. Well, what are we really doing here? Really, we're just using the distributive property. I'm multiplying x to everything, and I'm multiplying y to everything in the parentheses. This is FOIL. FOIL is essentially the double distributive property. Okay? So here, I'm going to treat it the same way. All right, I'm going to multiply everything. If I'm multiplying a trinomial by a binomial, I'm going to multiply everything that's in the first set of parentheses to everything that's in the second set of parentheses. But what would that look like? If I multiply 3 to x squared, I'll get 3x to the 4th. And then 3 to 2, I'll get plus 6x squared. I'm going to do the same thing with x. X times x squared plus x to the 3rd. X times 2 plus 2x. And the same thing with my negative 5. Negative 5x squared minus 10. So now what I want to do is combine my like terms, all right? And I'm going to keep everything in standard form here. So I'm going to write 3x to the 4th. Okay, that takes care of that. All right, my next highest degree term is x cubed, so plus x cubed. I have 6x squared and negative 5x squared to give me plus x squared. The positive 2x is alone, and the minus 10 comes along for the ride. There you go. Fun stuff. All right, there are a couple special products that we're going to deal with multiplication, okay? Obviously, all 3 of these you have seen, okay? But we're just going to review them. All right, you've seen these in some at some form in your mathematical careers, whether you realize it or not. Okay. This one here, the special name. Okay. I'll get to the name at the end. But once you start to recognize these, you start to recognize the quote-unquote shortcuts and be able to skip this step. So if I were to FOIL this, right, I'd get a squared minus ab plus ab minus b squared. And these would cancel. So I would get a squared minus b squared. Well, remember, this is the difference of two perfect squares, a dots problem, which is from your second year algebra course. Okay. If you see this in factoring, you should be able to go backwards to that. Or if I see that, I could be able to jump straight to that as well. Another one, a plus b squared, remember, is not a squared plus b squared. It's a plus b times a plus b. And if I were to FOIL this one out, I'd get a squared plus ab plus ab plus b squared, which would give me a squared plus 2ab plus b squared. Okay. Similarly, same idea, a minus b quantity squared is the same thing as a minus b and a minus b, which is again a squared, whoops, let's go red, which is a squared, or I'll try to, still not working, minus ab minus ab plus b squared minus 2ab plus b squared. All right. There's a second one when we're dealing with trinomials. It's called SOAP. Okay, SOAP, which you saw in your second year algebra course. Same, opposite, always, positive. Always positive. All right, so what does that look like? If I have a cubed minus plus b cubed, if I wanted to factor that, I need to figure out what term is being cubed here, what term is being cubed in the second term. Well, a is being cubed and b is being cubed. All right, so what does this come? The same sign, so this is plus, same. Then it's a squared, opposite sign, ab, and always positive for b squared. Okay, I'm going to write down the a squared minus b squared one, or a cubed minus b cubed. Okay, and I want to do an example for it. So if I have a cubed minus b cubed, it's going to be a minus b, then a squared plus ab plus b squared. Let's try an example. 8x to the third minus 27. All right, so what is being raised to the third power? Well, here, 2 and x are both being raised to the third power. Minus, what to the third power gives me 3, or excuse me, 27, it's 3. So this step you may be able to do in your head, you don't even actually need to write it. What it helps me with is identifying my a and b terms, okay? My a term here is 2x, minus my b term, which is 3. 2x to the third gives me 8x cubed. 3 to the third gives me 27. So then I want to square my a term, which means I have to square the 2 and square the x. Always positive, or opposite sign. A times b, 3 times 2x, which gives me 6x, don't forget the x, plus, always positive, b cubed, which is 9. So if I were to factor this, my result would be that. All right? Those are polynomials. So much fun.